Hi everyone, this is Math 110 and section 3.6, exponential trend lines. And I'm going to do one of the homework problems in Lumen as a video solution. So this happens to be question number 5 in my Lumen instance. And what we have here is some actual data. We are given the number of cases of polio in thousands of cases for various years. So notice here that it says years since 1980. So this first 8 represents the year 1988, 8 years since 1980. This second represents 1992. That's if I added 12, 1980 plus 12 years, the years since 1980, that give me 1992. And in 1992, there were 138,000 cases. All right, so a lot of times when working with actual data, I don't write all the zeros because they become sort of unwieldy in a big table. I represent them in thousands of cases, but that'll be important as we work through this problem. All right, so what my goal is that I want to come up with a model. I want to model this data, and I want to create a formula or a function that models this data. And I'm going to use Excel to do that. So I'm going to look at a scatter plot of the data, and then I'm going to decide which model is better. So I'm going to come over here. I already have this pre-populated here. So I've entered the data, years since 1980, thousands of cases of polio. And so let me just select this whole table, and then I'm going to insert. And then I'm going to go here to the scatter plot. And now when we're doing modeling, we're always going to use this scatter without lines versus when we are actually given a function, we use the smooth line graph. So I'm going to use the scatter, right? And then I'm just going to slide this over here. And when I look at this to begin with, I can already see the problem asks us, does a linear or an exponential model best represent this data? And I can see this is decreasing, right? And it's concave up. It's concave up. It also doesn't go through the horizontal axis. I don't have an x-intercept or a horizontal intercept. I would never have negative cases of polio, right? So it's going to end up being, this is an asymptote on the right-hand side. So all those things are telling me that it is more exponential than linear. So what I want to do is, see I'm in chart design here. If you're on a window, I'm on a Mac, so if you're on a Windows, you might see a plus sign here to give you options for the chart. Or if you go to this add chart element, I'm going to come down and I'm going to go to Trendline. And the default is none. But when I come down here, I always use this more Trendline option because it gives me the full option menu if I click on that rather than immediately clicking on one here. So I'm going to click more Trendline options. Okay, and you can see here that it started off with a linear function here. And these are all different options for, you can see I'm formatting a trend line here. So I don't want linear. That doesn't look like it matches the data very well. Let me try exponential. So I toggle there to the exponential. That actually looks like it fits the data much better. All the dots are closer to the trend line that I've drawn here. And that's key. And so then what I want to do is I want to come all the way down here and I want to display the equation on the chart. And it just sort of plops it right down there. I'm going to drag that up. I'm holding my left mouse key. I'm dragging that up. So now let's look at the problem again. So we've already determined that an exponential model looks like it fits better. And then it wants us to put the equation in this form. My function is equal to my A, my initial amount, times my factor raised to how much time has passed. And it wants us to round to 2 decimal places. All right, so let's go back to see what we have here. Well, notice it gave me the trend line with an E as a continuous growth. That's not what the question is asking for. It wants me to convert this E to the R to a B, to a factor, right? It wants B. So I want you to remember, let me go here, a couple things. Remember that e to the r, my continuous growth, my base of e raised to a growth factor or a decay factor is approximately equal to b. So if I look down here, f of x equals ab to the x, this is just regular exponential growth. Regular exponential growth where I have a is my initial amount, b is my growth factor. When I'm talking about continuous growth, I still have a as my initial amount, but you see here e to the r, e raised to the rate is approximately equal to b. All right, so if I want to get b, I've got to convert that e. I've got to convert that e to a b. All right. So let's look at what I have here. If I look at the formula that I'm given, I'm going to click on that again. You can see I don't have two decimal places. You can't assume that this number here doesn't have any decimals, and this is 3 decimal places. So I want to continue to format that trend line, so I just have 2 decimal places. So if I go to label options and I click on this bar chart here, you can see I've got now formatting for numbers. Just like if I'm formatting a cell in Excel, I can format this whole formula here. So I want to select number. I want to make sure I have 2 decimal places. You see how it's changed here. Now this is 3663.02. And I'm going to get rid of these separators. Okay, so now it's in the form that I want. I can see that I can convert that e to the negative 0.3 to a b, and that's what I'm going to do down here, and that's what I've done here. So b is approximately equal to, when I want to put the exponential function in, I type equals exp, and then what I put in the parentheses is that rate. All right. And so when I do that, and now I'm just going to make that 2 decimal places. So b is approximately equal to 0.74, and a is equal to approximately 3663.02. So that's what I'm going to put in here, 3663.02 and 0.74. And I can check the answers here and see that I've got that correct. All right, so then the next part here says the number of cases of polio is what? Increasing or decreasing? Well, every year that goes by, the number of polio cases is going down, it's decreasing. And how much is it going down? It's going down. We want to find what the rate is, or the percent decrease that it's going down. B is my factor. So I want to find what, let's see what my answers are here. All right, it's not going down by 74%. If I want to convert this B to an R, I know that B is 1 plus R. So I would say B minus 1 is equal to R. So it's going down by 26% per year. So it's decreasing by 26% per year. And I can see, check those answers after I submit them. Okay, so good, I've got that. Now it says predict the number of cases of polio in 2018. So when we're going to do a prediction, that's where now we're going to use this model. So what I like to do is set up a whole separate section underneath my model. So I use my actual data to create the model. So down here, I'm going to use that model. I'm going to use that model to make any predictions. So I set up my input-output table. The first column here is years since 1980, and then number of cases of polio in thousands. So I'm just going to start, year 0 would be starting at year 1980, and then I type my formula in, right? This is equal to 366.02 times my B, 0.74, raised to this T value, which happens to be in cell A18, okay? And then I'm just going to go by 5 years. So I just made my inputs go. So this would be 1985, 1990, 1995, 2000, etc. All right. And I copied or filled the rest of that table down. So this wants to know how many cases were in 2018. So I could do a couple things. I put this extra column here to just show me that what is the actual year, right? So I can just add 1980. So if I wanted to find out how many years is 2018, I could say equals 2018 minus 1980. That would be 38 years after. So if I look here, I don't have 38 in my input, right? So I'm going to pick the cell closest to 38, and I'm just going to type it in, and then Excel will do the calculations. So I'm going to type 38 in here, and that represents the year 2018. And it tells me that I have 0.039322.819 cases of polio. But remember, this is thousands of cases. So if I want to figure out how many cases exactly, I would say that's equal to that times 1,000. So this is telling me that I have 39.32 cases. That's what the model is telling me. And so this wants to know the number of cases to the nearest case. I can't have partial cases, so I would write 39 cases. Okay, it gave me the input, which is years, and I just typed that in my table, and then because my formula is here, it calculated the number of cases. All right, so then it wants to predict the year when the number of cases will be 1. All right, so that means if I have 1 case of polio, and in thousands of cases, that translates into 0.001, right? So if I did here, times 1,000, right? So right here at 50 years, that's closest to 1 case, but I want to know exactly, and that's where I'd use solver, right? My input is the number of years since 1980, my output are the number of cases. So if I want to force the number of cases, which my output, to equal 1, I'm going to come right here. That would be an output value of 0.001. All right, so when I'm given an output, I use solver to solve for the input. So I'm going to go to data, solver, and I want to set my objective. I want to force cell B28 right here to exactly equal 0.001. And where do I want to put the result? Well, I want to put it right next to it in A28. A28. I'm going to unclick that. Okay, I'm going to keep that. All right. So I have my answer now. I know that 50 years since 1980, I will have about 1 case of polio, and that's in the year 2030, right? I would need to add 50 plus 1980, and that happens in the year 2030, okay? So this just wants the nearest year. All right. And now the last one is a little bit tricky, but it says find the approximate half-life of the cases of polio. Half-life. So the number of cases will be cut in half. How many years? Well, let's start off here. We started measuring in 1980, all right? 3663. If I wanted to find half the cases, I could just say, well, I want that to equal half. Forgot my multiplication sign. I want that to equal half. So I want my number of cases to equal 1831.51. So what I'm going to do is that's an output. So I'm going to use solver. I'm going to force this cell here is closest, 812. So I'm going to force that to equal 1831.51. So I'm going to do data, solver. got to get that out of there. I want to force cell B19 to equal a value of 1839.51. And I want to put the result right next to it right here. Okay, and I want to solve. Okay. So I can see here that about every 2.29 years, that's how long it took for the number of polio cases to be cut in half. All right, so this says round to 2 decimal places, so I'm going to round this 2.29. Every 2.29 years. Okay, it should work. That's got 1 decimal place, but every 2.29 years or 3 years, the number of cases is cut in half.